All right, our last section in chapter 1 of kind of things that we're reviewing old topics is about circles. Now, obviously, we all know what a circle is, but if we want to have the formal definition of a circle, it's all points who are the same distance from a center point. So we have some point in the middle, and then all the points that are equal distant from it make a circle. So if you have a point here, we'll call this our center point. So if I take all the things that are the same distance away, I start getting these points. So if this is the same, all these points are the same, and they make a kind of terrible circle. So we call this distance to these points the radius. So these are all the radii. And then obviously, if you talk about all the way across a circle, that is called the diameter. So we're really more interested in the algebraic equations of circles, as we'll see several of those this year. So the equation of a circle with some center, we'll say the center is generically hk, and we'll say the radius is r. It is given by this equation. X minus h squared plus y minus k squared equals r squared. So this is what's referred to as the standard form of a circle equation. So just a real quick example, if I had maybe a center of 1, 3 for a problem, and then maybe I gave it a radius of 2, then its equation would simply be x minus 1, because I'm doing x minus h, this is k, squared, plus y minus negative 1, which is y plus 1 squared, equals 2 squared, which is 4. So if I were to graph this, I would get a circle that has a center of 1, negative 1, and a radius of 2. So we're just going to do a variety of equations. We're going to talk about what's called the general form of a circle equation and how we can put it into standard. But we'll start with this example. It says we want to find the equation of a circle with a center of 2, 3, passing through the point 4, 8. So I know my circle equation is going to look something like x minus 2 squared plus y minus 3 squared. The problem is I don't know what the radius is. So I can't really finish this problem. So what I'm going to do is I'm going to have to find that radius. So I'm going to go ahead and say, let's say this is 2, 3 on my coordinate plane. 1, 2, 1, 2, 3. There's my center. And then I'm saying the point 4, 8 is also on this. So there's 4, 8, and this is 2, 3. So I'm really just trying to find out how far that distance is between those two, and that's going to be my radius. Well, earlier we have a formula to find the distance between 2 points. So remember, distance is going to be square root x sub 1 minus x sub 2 squared plus y sub 1 minus y sub 2 squared. So since we have 2 points, we'll just substitute those in. That's going to be square root. We'll say 2 minus 4 squared plus 3 minus 8 squared. So if we find this distance, this is going to be the square root. That's going to be negative 2 squared. And that's going to be negative 5 squared. So this is going to be square root of 4 plus 25, which is the square root of 29. So this distance here is the square root of 29. So whatever that is, a little over 5 units. The distance from that center to that edge is square root of 29. Now obviously in our circle equation, this has to equal r squared. So r squared, if I get rid of the square root, because I square the square root, it simply just becomes 29. So this is going to become our equation of our circle with that center that passes through that point. You can check very quickly and make sure it does work. If I plug in 4 for x and I plug in 8 for y, this should give me 29, which it does. 2 squared plus, this is minus, so that's plus 5 squared, which is 29. Now, the other thing we have that's not standard is the general equation of a circle. So the general equation of a circle is really when all terms are expanded, you can put it in what's called general form. We generally don't like things in general form, so we would prefer them in standard, but it's a pretty important form. So what it's going to look like if you have something in general form, it'll be x squared plus y squared plus some number x plus some other number y plus some other constant equals 0. So essentially, instead of having x plus 3 or x minus 1 squared, it's already been FOILed out. So this equation is obviously in standard form. X plus 2 squared plus y minus 4 squared equals 64. So if I wanted to put this in general form, maybe just to something easier to put in a calculator, not a real lot of benefits to general form. But if I wanted to, I could just FOIL out x plus 2, which is x squared plus 4x plus 4. And then I could FOIL out y minus 4 squared, so the square is on the outside. So that's going to give me y squared minus 8y plus 16. And then that equals 64. So if I just start writing it, I have the x squared, I have the y squared, I have the 4x, I have the minus 8y. Now the numbers 4 and 16, those guys are going to come together to become 20. So that is going to become plus 20 equals 64. So if you want to put it in the kind of normal form, what we're going to do is we're just going to move that 64 over. So x squared plus y squared plus 4x minus 8y minus 44 equals 0. So that's general form. No, that's fine, but that's kind of we would prefer it to be in standard form. So we did this, we went from standard to general, just to show you that we will eventually want to go from general back to standard. So I'm going to want to start here and go back to here, okay? So the way we're going to do this is by doing what is called completing the square, okay? You've probably heard of completing the square from Algebra 2, where you're trying to make perfect square trinomials. We're trying to do the same thing here. So let's go ahead and look at an example of how we could complete the square. So what I'm going to do is I have in this problem x squared plus y squared minus 4x plus 6y minus 12 equals 0. So what I'm going to do is I'm going to try to arrange these because some of them have x's, like this one. X squared minus 4x, those have x's. And then I'm going to kind of put the y's together, so that's going to be y squared plus 6y. Now I'm going to go ahead and move my constant to the other side. So I want to have everything that has an x on one side kind of grouped together, everything that has a y by itself kind of grouped together, and then everything else kind of on the other side. So what we're going to do is we'd like to turn these. Remember, the whole goal is to get these to be like x minus or plus something squared. So the way that we're going to do that is we want to try to factor these as perfect square trinomials. Now, the factors of perfect square trinomial, this number has to be a special number based on this middle number. Now, the way it works is this number at the end has to be half of that middle number squared. So if I have to take half of negative 4, it is negative 2, and if I square it, that becomes 4. So the number I want to add to the x's is 4, but of course I'll have to add it to the other side. And I'll show you why that's important. Same thing for the y's. I want to take half of the 6, which is 3, and I want to square that, which is 9. So I'll add 9 here, and I'll add 9 here. So what happens is if you look at these three terms and you think about how those factor, two numbers that multiply to 4 add to negative 4, that's x minus 2, x minus 2. Well, the nice thing is it's the same thing. It is a perfect square trinomial. We kind of made it that way. I can write this as x minus 2 squared. And that's how we kind of start to make this look like standard form. Same thing for y squared plus 6y plus 9. It's going to be two numbers that multiply to 9, add to 6 are going to be 3 and 3. And that's going to be plus y plus 3 squared. And you'll notice that the number here, 3, is the same here, and the number negative 2 is the same here. That actually always does work. And then finally, we just add the other numbers on the other side, and I get 25. So this circle has a center of 2, negative 3, a radius of 5. That would have been very difficult to see originally in the general form, but when you put it in standard form, not so hard at all. All right, so just a couple more to practice doing this general form. So we have 3x squared plus 3y squared minus 12 plus 4 equals 0. Now this is somewhat problematic because for a circle, we have to have just x squared and y squared. We can't have those 3's. So what I'm going to do is, it is a circle because as long as they're the same, it is a circle, but I'm going to divide everything out by 3. So that's going to give me x squared plus y squared minus 4x plus 4/3 equals 0. So you have to make sure that you have just x squared and y squared, just like you do for standard form. Okay? So now if I go from this, what I want to do is I'm going to regroup. So I'll put the x squared and the 4x together. Now there is nothing for the y squared. It's just kind of by itself. There's no y term. Equals negative 4/3 if I move that to the other side. So to complete the square on the x, I'm going to take half of negative 4, which is negative 2, and square it, which is going to give me 4. Now the y's, I don't have to do anything for. There's no completing the square. It's just y squared. So when I factor this, it's two numbers that multiply to 4, add to negative 4. It's also right here. It's x minus 2 squared plus just y squared, regular old y squared. And then I get negative 4/3 plus 4, which is 8/3. Now this problem actually wanted to know about the length of a diameter. I mean, I could do the center. The center, it's not asked for, but it's just 2, 0, because if there's nothing for the y, we just consider it to be 0. Now the radius is going to be the square root of 8/3. Because remember, this is r squared. So if you take the square root, you get your radius. So the diameter, if I wanted to find it, would be 2 times the square root of 8/3. Okay. Now it's obviously an irrational number, so if you actually were to measure this length, it would be some, crazy decimal, but that is actually the exact value of this diameter. All right, finally, we have just another one. We're just changing standard form. Nothing too crazy about this one, just one we kind of regroup. So x squared minus 8x plus y squared plus 6y equals 14. That's just getting the x's and the y's together and things like that, putting the other number on the other side. So what I want to go ahead and do is I'm going to do the complete the square. So if I do half of negative 8, I get negative 4. Squared is 16. It's just negative 4 half squared. So I add 16 here. And if I do half of 6, it's 3. 3 squared is 9. So I get y squared plus 6y. Got to add 9 here too. Plus 9 equals 39. So this is going to factor as x minus 4 squared. Two numbers that multiply to 16 add to negative 8. This is going to factor as y plus 3, so y plus 3 squared equals 39. So center of 4, negative 3, and a radius of square root of 39. So hopefully this kind of jogs your memory about the equation of circles. So when we see these in the future, we'll be ready to deal with them.